What is going on, guys? Welcome to the episode number 6 of the Python tutorial series for beginners. Today's video will be about sequences and collections. Now, in the last video, we mentioned that we can use for loops to iterate over sequences, but we didn't really talk about what a sequence actually is. Now, in this video, we'll get an overview over the different types of sequences and collections in Python and what we can do with them. So first of all, what is a sequence? A sequence is basically just a collection of elements. So instead of having one value assigned to a variable, we can now assign a whole collection of values to a variable. So one structure, one object that contains multiple values but can be treated as one thing. Now, before we talk too much about the theory here, let us get into the code. So the first sequence type that we're going to talk about today is the so-called list. And to define a list in Python, we use so-called square brackets. So I can say my list equals, and I use square brackets to define that what I'm doing right now here, or what I'm creating right now here, is a list. And in between these square brackets here, I put all of my values separated by commas. So let's say 10, 20, and 30. This would now be a list of the length 3, and it will have 3 integers as elements. And what I can do here is I can print the whole list as a whole object, print my list. And when I run it, you see 10, 20, 30. Now this object contains these 3 values. Notice that Python's typing here is again dynamic, so we can mix various data types. In most other programming languages, we would have to define the data type of the list. So in Java, for example, I would have to say int array or int list, whatever, my list, to tell the compiler in Java that this right here is an integer list. So it would not be allowed for me to enter a string here because it's not dynamically typed. In Python, this is no problem. I can just define my list and I can put all kinds of values in here. So true, 8.97, whatever. I can add multiple values here and it will still work out well or fine because it's dynamically typed. Now, one thing to know about sequences is that most of them are indexed. And an index is basically just a number that gives us information about the position of an element in our collection. So in programming, we start counting from 0. So the first element here would have the index 0, the second one would have the index 1, and so on. So we use indices to access individual elements. So maybe I'm not interested in the whole list, I'm interested in this string here. And to get this string, I just have to specify the index of the element I'm interested in. So I have my list as a whole object, and I can use my list to access individual values of that list. So I specify square brackets here, and in between these I put the index of the element. In this case it would be 3 because it's position 4. We always subtract 1 and we get the index. So my list 3 would be the string. Now, of course, you cannot just specify any number, because if you go out of the range here, if you, in this case, we have 6 elements, so the highest index will be 5. And if we, for example, try to access index 9, this would give us an error, index error, as you can see, because the list index is out of range. Now, another thing that we can do here is we can access slices of this list. So maybe we're not interested in the whole list, we're not interested in one value, but we're interested in, let's say, the first 3 values, 10, 20, and 30. And what I can do here is I can specify the slice that I'm interested in. So in this case, it would be from the beginning, and then I use a colon sign to say from the beginning up until, and in this case, I enter a 3 to tell the interpreter up until index 3, which means that index 3 is not included. So when I have something on the right side of the comma, it's not included. So in this case, it would be index 0, 1, and 2, but not index 3. So I would get the first 3 numbers. However, and this might be a little bit confusing when I put something on the left here, it is included. So I can specify a range 1 up until 3, which would use index 1, which would include index 1, but not index 3. So I would get 20 and 30 here, as you can see. So just remember, the element at the index of the right side here is not included, but on the left side it is included. And another thing I can do is I can access elements from right to left. So maybe I don't want to say index, I don't know, 4, sorry, but I want to say the second element from right to left. And this might be also confusing, because when we say we want to index or access from right to left, we use a minus, but we then start counting from 1. So if I want to access the true here, I have to specify -2, whereas when I access it from the left, I start counting from 0. So 0, 1, 2, 3, 4, but here it's 1 and 2. So in this case, -2 would give me the second element from right to left. Now we can use the same notation to manipulate or change values of a sequence. So we can not only access them for reading, but I can also say my list, I don't know, let's change the string. My list 3 would be now another string. We would just replace the value of this index or at this index. So print my list, run it, and you can see that I replaced the string. Of course, it does not only work with the same data type, so I don't have to replace a string by a string. I can also replace a string by a number. Let's say 6.54. And instead of a string, I would now have a number here. So it's totally fine. We can just replace all the values. What we cannot do is just append a value. So I cannot say index 6 that does not exist is something, because for this we will get to know a method, but we cannot just access an index that is not assigned yet or is not there yet. Now, last but not least, before we get into list operations, functions, and methods, let's quickly take a look at how to iterate over lists with for loops, because this is something that we talked about in the last video. Now, it's quite simple actually. All we have to do is we have to say for some control variable x in my list, and then I just print x, for example. In this case, it would print all of the values one after the other, because with every iteration, x, the value of x becomes the next element in the list. So I start with x being 10 in the first iteration, 20 in the next iteration, and so on. And we can just print all the values or we can process them. So if we have a list of numbers, 1, 2, 3, 4, 5, I can, for example, just print 2 to the power of x, which would give me all the powers of 2 up until 5. And I can use the values of the list for or as an input, as you can see. Now let us talk about what we can do with these lists. First of all, we can perform some basic operations on lists. For example, we can just add two lists to append one list onto the end of another list. So list x is 1, 2, 3, and y is 4, 5, 6. And when I add these two lists, I don't get the result of 1 plus 4, 2 plus 5, 3 plus 6 or something like that. I just add one list at the end of another list. So x plus y would give me just a new list which has all the numbers in it. Of course, this works with all kinds of data types. So it doesn't have to be the same data type. We just add the two lists. We just merge them if you want. And another operation that we can do here is we can multiply lists by scalars. So if I multiply x, for example, by 4, what I'm doing here is I'm not multiplying 1 by 4, 2 by 4, 3 by 4. I just repeat the list 4 times. So I get a new list with the same values 4 times in a row. Besides that, we cannot use any operations really, because we cannot subtract lists, we cannot add numbers to them, we cannot divide them, we cannot multiply a list by another list. So these are basically the operations that we can do. We can add two lists or multiply a list by a scalar. But what we do have is a lot of different functions and methods for lists. So let us first have a look at the three basic functions of lists. So just lists, functions that give us some information about a list. And these three functions would be len, max, and min. So the len function gives us the length of a list. In this case, how many elements the list contains. So in this case, it will be 3. So len x would be 3. We're going to print that in a second. Print. So the length function basically just tells us how long the list is, how many elements it contains. The max value and the max function and the min function always return the smallest value and the biggest value of a list. So max of x would be 3 and min of x would be 1, of course. And of course we have to print that as well. Print There you go. Oh, I forgot a parenthesis here. So as you can see, 3, 3, and 1. So length of 3, max value of 3, and the minimum value of 1. However, take care here, because if I have a string in here, hello, or a boolean, we have a problem, because I can still get the length of this list, in this case it would be 5, but I cannot get the maximum value and the minimum value, because you'll see that I cannot just compare with this comparison operator that we already know. I cannot check if a string is greater than an integer. With some data types it works. I can check floats and integers, but I cannot really check if a string is bigger or larger or less than an integer. So we would get this error here, this type error. So these are the three basic list functions. Now let us get into some list methods. And there are a lot of interesting methods, but it would be too much for one video to cover all of them. So in this video, we're going to focus on the most important ones, especially for now. Probably the most important list method is the so-called append method. What it does is it just appends one value at the end of a list. Because we said we cannot just say x of, in this case, the biggest is, I cannot just say x of 5 equals something, because the index does not exist. But if I want to add a value to a list, I just say x.append and some value. It can be 6 or new value as a string. And when I then print the list, you'll see that there's a new value in it. So this is the basic append method, just adding one more value to the list. Now, if we don't want to add this value at the end of a list, but we want to add it as a specific, we want to insert it at a specific index, we can use the so-called insert method. So x.insert, and then I have to specify the value and the index, for example, 2. Oh, sorry, the other way around. First the index, then the value. So at index 2, I want to access, I want to put the value new value, and as you can see, it now shifts everything to the right, so it goes to index 2 and shifts the 3 values to the right and inserts the value new value at the index 2. Now, if we don't want to add an element, but we want to remove one, we can use the remove method. The remove method just accepts a value, so x.remove, and not an index. So I don't remove an element at a specific index. I say remove the value of hello, for example. And it would just remove the value hello if it's contained in the list. If not, for example, ABC is not contained in the list, or it's not contained in the list, then of course we get an error because X is not in list, value error. We cannot remove something that's not there. However, if you want to remove something at a particular index, you can use the pop function, because the pop function allows you to remove an element at a specific index without knowing what this element is. So maybe I want to remove the value or the element at index 2. In this case, this would be 3. And when I say x pop 2, we no longer have the 3 in there. Now, another useful method here is the so-called index method. What it does is we basically pass a value to it, and if this value is in our list, if the list contains this value, this method returns the index of the element to us. So when I say x index hello, it would return to me, I would have to print this, of course, print yeah. So if we print the index, we get 3 as a result, because the element hello is at the index 3. And what I can do, of course, is I can say x.pop x index hello. This would basically just pop the element at the index of the value hello. So I would get first the index of the value I'm looking for, and then I can pop this element. So it would basically just remove hello. This is just a remove method if you want, but it works, as you can see. And last but not least, let's talk about the sort method. And this method basically just sorts our list. So if we have a list of 1, 2, 3, 4, okay, this is already sorted. Let's say 55, 6, 1, 99, 2, 3. What I can now do is I can print x, or no, first I say x.sort, and then I can print x. And as a result, you'll get a sorted list. So 1, 2, 3, 6, 55, 99. And this method basically sorts our list. Now there's an alternative to that. We can also use the sorted keyword. So I can say print sorted x. This is a Python function which just returns the sorted list. So you can either say x.sort, or you can just return the sorted version of x. The difference here is that if you say x.sort, it really changes the list. So it's now a sorted list. X becomes this list. And if you just print the sorted list or the sorted version of x, you just print it, but x still remains the list it was in the beginning. Now let us get to the next type of sequence, the tuple. Tuples are exactly like lists except for the difference that they are immutable. So we cannot change the values or the structure of tuples. And also they are defined with parentheses and not with square brackets. So I have the list 1, 2, and 3, or I have the tuple 1, 2, and 3. Now, as I said, they're exactly the same except for the difference that we cannot change a tuple. So we can still get the length of a tuple, we can still access the individual elements of a tuple by, for example, just saying print y2. This would give us 3 because we can do the same thing. But what we cannot do is we cannot change values. I cannot go ahead and say y2 equals 10, for example. This is not possible because a tuple is immutable. As you can see, type error tuple object does not support item assignment because a tuple stays the same. We can, of course, use the same methods and functions that we use for lists, except for all of those who manipulate something. So we're not able to sort a tuple, for example, because a tuple has to remain the same. We cannot just change the order. It stays exactly the same. However, if we have a tuple, for some example, some functions return tuples, some inputs are tuples, some data which we will load is a tuple. If we want to change it, we can just typecast it. So let's say x is the tuple here. What I can then do is I can say x equals list of x. And now, of course, I could also change the values, even though it's a tuple. And I will then have a list. Of course, I can then typecast it back into a tuple. So after changing the value, I can say x equals tuple, x again. And I would have again an immutable tuple with a changed value. The last sequence type that we're going to talk about today is the dictionary. Now, dictionaries work a little bit differently than the other sequences because they're composed of so-called key-value pairs and they're not indexed. Now, a key-value pair consists of a unique key, which is the replacement for the index, and a value that belongs to that key. So to access a value of a dictionary, we don't refer to the index, but to its key. For example, we could define the dictionary person, and this dictionary would have different keys and different values. Now, a dictionary is always defined by curly brackets, so not square brackets, not parentheses, but curly brackets. And we can start by specifying the first key here, and a person could have a name. So the string name would be the key that we access to get its value. And the value to this key, the value that belongs to this key, comes after the colon here. And in this case, we could say this is Mark. And then we separate again this key value pair here. So this right here is a key value pair. And I separate it by a comma from the next key value pair. And the next key value pair could be age and 25, for example. And the next one could be gender and male, whatever. So this would be a dictionary with 3 key value pairs. So I could print the person dictionary here, and this would be the whole dictionary. Now, if I want to access some value here, I don't say give me person 0 or person 1, doesn't work, but I say give me person H. So I use the key to get the value. This is why the key has to be unique, because I can have multiple keys, different keys with the same value, but I cannot have the same keys, because if I have 3 times name, when I access name, what result will I get? I have to have a unique key. So when I access H, I get 25. When I access name, I get Mark. And of course, the key doesn't always have to be a string, at least not in Python. I can also have true as a key. It's quite stupid, but I can have true as a key, and 88 is a value, for example. So when I say print person true, I would get 88. It's not very reasonable to use a Boolean as a key, but you can do it. Now, to add a new key or a new key value pair to this dictionary, what we do is we say person new key equals some value, I don't know, 67. And when we do that, so we don't have an append method here, we just specify a new key and it works. So print person would now have another key value pair. At the end, new key 67. So now let's talk about 3 very important dictionary methods, because they're quite useful to us and they're quite similar. And these 3 methods are items, keys, and values. And you might already guess what they're going to do. For example, when we say print person items, what this does is it returns a list of all items, of all key value pairs. When I say person dot key, or keys, sorry, it returns a list of all the keys. So name, age, gender, true, new key, and so on. And when I have person dot values, I get all the respective values. So these are very important dictionary methods that we can use. So actually, it's not a list. I said something wrong here. It's actually, if you look at it, it's a tuple of a list of tuples. So we have a tuple, dict items, which contains a list, and this list contains the tuples of the key value pairs. And if we don't have pairs, we just have a tuple of a list with elements. So if you're interested in more list functions, list methods, just check out the Python documentation, because as I already said, I cannot go into all the functions here and how they work, because this would be way too long for a video. But if you're interested in them, check out the link in the description. You'll find a link to the documentation of dictionaries, lists, tuples, and so on. And there you can read a lot about the different functions and methods that you can use. Now, the last point for today's video are the so-called membership operators, and also an operator type that we also skipped in the third part, namely the identity operators. So membership operators, the 2 membership operators are in and not in, and they're quite simple to understand because we've already used them in for loops. And what they basically do is they check if an element is contained in a sequence. So they return true or false, so a Boolean. And when I say print, or first of all, let's define a list x equals 1, 2, 3. And now I can print 2 in x, and I can print 7 in x. And of course, the first one will return true and the second one false, because 7 is not contained in x and 2 is contained in x. And of course, I can use the same with not in, just negates, as not is actually just a logical operator. So not in would negate in, which would just flip the results. And the 2 identity operators that we need to talk about are is and is not. Actually, they're not very related to the topics of sequences, but I thought since we skipped them in the operators video, right now might be a good place to talk about them. And basically, they're quite simple. They just check if something is a type, for example. So I can have a value x equals 10, and now I can check if type x is int, I can print x is int, and otherwise I can print x is not int. So in this case, it will print x is int, and if I make x to be a string, x is not int. So the is or is not, we can also use is not like this. These identity operators just allow us to check if something is the type of something. So that's everything to know about sequences and collections for now. In the next video, we're going to talk about functions and parameters. There's a lot more to learn here, so stay tuned and keep watching these videos. If you liked the video, please hit the like button. And also, if you want to see more, subscribe to this channel and feel free to ask questions and give feedback in the comment section down below. Thank you very much for watching and see you in the next video. Bye.